Hi, Bissan.
Hi, Anand.
It's very nice to have you here today. How are things?
Good. Thank you for having me. It's really nice to talk to you today.
Yeah, it's my pleasure. So, today my guest is Bissan Ghaddar. She's the John M. Thompson Chair in Engineering Leadership and Innovation and an Associate Professor of Management Science and Sustainability at the Ivey Business School, working on problems at the intersection of machine learning and nonlinear optimization. Her work has been published in prestigious journals such as Mathematical Programming, Informed Journal Computing, Science Journal on Optimization, among others. She serves as the research lead at the Ivey Energy Policy and Management Center and is a fellow at the Bausili School of International Affairs, engaged in the research cluster on AI, global governance, and international public policy. She is an associate editor for the Euro Journal on Computation Optimization, and she was recently awarded the Best Survey Paper Award at the Euro Conference in Copenhagen and the Distinguished International Associate by the Royal Academy of Engineering. Bissan, thank you very much for accepting the invitation. I hope to have
Thank
a nice
you.
conversation with you.
Thank you for the introduction and looking forward for the discussion.
Yes. So, Bissan, you were born in 1983, just like me, but you're a little bit younger in Lebanon. Do you come from Beirut or from somewhere else?
Yeah, I was born in Beirut, and it's the capital of Lebanon. It's a really vibrant city. It combines both the traditional side of the history and the culture, but also it's very fast-paced and has the modern lifestyle and modern vibes.
Yes, I wish to have the chance to visit Beirut one day. I have heard so many good things about the city. And let's hear about your family, starting with your parents.
Yeah, so my parents are like my mom is a chemistry teacher, and she's right now currently the school principal as well. She has been teaching for the past, I would say, 40 years and plus. And my dad is retired, but before he was a journalist and a government employee. They've been both working for most of their lives, and yeah.
Do you have a periodic table just like I have it here? Because my parents are chemists.
Yeah, like my mom, growing up, I also used to go to some of her classes for the high school teaching. So I used to be very familiar with the high school chemistry program and as well as the periodic table. I've seen it so many times growing up.
Yes, very nice. You have two younger sisters. What careers did they pursue?
So my sisters are both in business. One is 4 years younger than me, and she's in finance. And the youngest one, which is 10 years younger than me, she's an accountant. So they both decided to go into business while I'm the only engineer in the family. So
Okay. Are you all very close to each other, the
yeah,
three
we're
sisters?
yeah, we're super close to each other, and especially growing up, like now we talk almost on a daily basis. And if we don't talk, like we just chat to make sure everybody's good. And unfortunately, we are now in three different countries, so it's a bit difficult for us to meet. But we try on a yearly basis at least to get together with my parents. But yeah, like distance is a bit far, and especially with kids, they have also their own kids now. It's a bit difficult to manage a meeting point and a meeting day.
Yes, I totally understand that. So, Bissan, you grew up right in the middle of incredibly turbulent times in Lebanon. In what ways did that time leave a mark on you growing up?
Yeah, like I was born in the middle of the Civil War. So, and our house was on the Green Line. So they call it the Green Line, which was really a war zone. And the day I was born, when my mom went back to the house, like when she took me back to the house, like there was a big explosion very close by. And since then, at that point, we moved and we kept moving for the next few years at that point. I think like I don't have a lot of memories about the war itself. I remember we moved to different places, but what I really I think had in terms of childhood is the memories that we spent with my parents and my sisters and also the grandparents. Like we used to go to my grandma's house on every weekend and have lunches there. I think that made me a little bit forget about the impact of the war, but at the same time, I think growing up and seeing a lot of things happening in Lebanon, I grew in a resilient environment, and that also shaped who I am now. It's really amazing how you see people like even like building things even when there's no hope or where there things seems impossible to rebuild again. So that was really something I really appreciated. So it's both, I think, about resiliency and hope. So being able to stand up after every fall or after every wall and build things from scratch. And at the same time, having hope that better days are going to come. Whatever happens, there's something good that's going to come out of it. And that is why I think I have certain aspects in my personality in a particular way.
Right. So, do you think you became stronger because you had that sort of circumstances while growing up?
Yeah, because you are living in an environment of uncertainty. Things are like normal in given days, but certain times, like there's a war or there are economical issues or other internal political factors that are impacting the country. So with all of this uncertainty, you have to adjust, you have to adapt, and you have to keep going. And being able to do that in different situations, I think that made me stronger. It's a bit sad, but at the same time, it made me proud. Like people there are very resilient. People there are hopeful. They would want to build things, and especially with the latest war this year, that the moment the war ended, the next day people were going back to their houses. They were building things again, and that provides you with a sense of okay, people are really hopeful and optimistic, and something eventually, hopefully, good will come out of this.
Right. And how did your family manage to find any moments of distraction during and after the war period?
So, like as I said, like growing up, I really have very good memories of my childhood, even though that it was not a good period in time. But my parents made sure that we are in a like safe environment, and playing board games was really something that helped us a lot. So even when there's no electricity and like you are only having the candles to see what you're gonna do or what you're doing, we used to play board games from Risk, Monopoly, Scotland Yard. I played a lot also of Pokemon with my dad as well. So these are really things that distracted us, and we were the four of us. So my youngest sister was not like still born at that point in time, but the four of us, me, my dad, and my mom and my sister, used to play a lot of these board games. And also being able to go to my grandparents and having lunch there every Saturday. So every Saturday we spend the whole day at my grandma's house, and my cousins would come. And this sense of family and community also provided me with a really nice memories of my childhood. And the city of Beirut is also, with all of its details and the nice streets and the walks that I used to have there, also is a nice memory. And I don't think like you can erase these even with whatever turbulent times that were happening. So I really have a very good memories of my childhood and of these past years being
So
there.
you guys managed to take the best out of the situation, right?
Yeah, I would say so, and I hope at some point my kids in the future would go there and see the things that I used to see, and experience some of the memories of the family, the community that I used to have growing up and being there.
Mm-hmm. Yeah, sometimes when we're exposed to difficult times and we're able to overcome the challenges, we tend to come out stronger. At times, depending on the nature of the challenges, is sometimes you have to learn a subject, sometimes we have to cope with a loss, sometimes we have to deal with a lot of uncertainties regarding economy and other things. And being able to navigate these waters is very, very important for one to develop resilience and other abilities, right?
Yeah.
So you mentioned Monopoly and Scotland Yard. I also used to play those games. And did you play any sports?
Yes. So at school, I used to play handball a lot. So especially like during the last years of school, and at the university, I started also playing basketball. And I'm not very tall to play basketball, but I was a good stealer, and that also made me part of the team, and I really enjoyed that. So for the 4 years of my university, I used to play basketball, and that was fun.
Yeah, what a coincidence. I used to play also handball and basketball in school, and I'm also very short. but I did not take that super serious, I must confess. And as someone from Lebanon, a country with a rich cultural heritage, were you interested in any form of performing arts back then?
Yeah, so sports, I didn't take it at the professional level, but arts was something that I really enjoyed from the school years, especially when I was like really young. I started doing theater. So I used to play in the school plays for every year during the end of the year play or the middle of the year play. So I really enjoyed that, being part of like the theater and acting in these plays, and that provided me with some like really sense of, okay, I'm doing something on top of the classroom and school academic work, I would say. So that's something I really enjoyed. And then at the last year of school, as well as the university, I was part of the team working or dancing, folklore dancing. And that we were performing in small villages and small town every summer. So it was something that was really nice, and we used to practice on a weekly basis. So it's something I took very seriously. We were practicing and we were performing. So that ended up when I moved to Canada. But until the last years of my bachelor's degree, I was still part of the team and I was still doing that. And it was something that I felt that provided me with some happy moments doing that.
Glad to hear that, and it's very, very impressive. Do you have time to dance nowadays?
No, unfortunately, after I moved to Canada with schoolwork and not finding the right maybe team, because folklore dancing was very particular for Lebanon and the region, and yeah, I didn't see it at least in other countries that I visited or been to. But dancing in general is something I really like and enjoy. Maybe someday I will take some classes again, or maybe my daughter would enjoy that, and we see.
Yeah, I hope so. Um, what was your music playlist during your teenage and early adult years?
So I would say a mix of two things. I used to really like Pearl Jam, Oasis, Nirvana, and this type of music growing up. And they were very popular at my time, I would say.
Yes.
But I also really liked the classical Lebanese music, Fairuz and Zaki Nassif, and these types of music that my dad used to play a lot in the weekends, for example, and in the morning, especially, and in the car when we are on road trips or going some places. So I also enjoy that. And maybe you think it's a bit of a contradiction between like super classical Lebanese music and like Pearl Jam, Oasis, and this type of music. But for me, it felt like I liked them both, and I enjoyed listening to both of them. And now, especially being away from home, I really enjoy the classical music, and I really put it a lot of times. Just it makes me feel back home, and it reminds me of a lot of things from back home.
Yes, very nice. Bissan, many of the guests I have interviewed were top of their class in school. Was that the case for you as well?
Yes, so when I started school till the high school years, I was always the first in my class. And in particular, math and physics, I got like really good marks in that. And maybe that also drove my passion later on to being like in the math community and being interested in math. But yeah, I was the first in my class, and that was something also for my parents. Like they kept encouraging me to do that, and that happened in this way. Yeah.
Yeah, I see this trend happening quite a bit with OR folks around. And in your last year of high school, you chose to pursue a math sciences program and ended up being the only girl in the class. How did you feel about that?
Yeah, so the last year of my high school, you had to decide whether you want to specialize in like social studies or in like technical studies like sciences. And there you had the option between biology and chemistry or physics and math. And I ended up deciding physics and math, but in that classroom, I was the only girl. We were 10 boys, and I was the only female there. To be honest, at that point, I didn't think about it as a challenge. I didn't even think that, okay, being the only female is a disadvantage or a weakness. I was more focused, okay, for me, I wanted to do engineering, and for that, I need to take the math and physics specialization, and that is the way to provide me with this opportunity. So I thought about it, okay, how do I get to what I want in the end, like in the next year for my studies? And that's the way to handle that. And also, like, the classmates that I had were very supportive. So I never felt like, okay, I'm in a different situation or I have a disadvantage being the only female. And now, maybe looking back at it, maybe it provided me with the confidence to be in an environment that's not diverse, for example, or where I was a minority being a female there. So I think maybe that's also one of the reasons that made me confident among different situations, especially in our area, like later on in university. Also, like, I wasn't the only female, but we were a minority, and later on also in graduate studies and during my career and my work. So yeah, it was a thing that I didn't realize at that point, but I think it was a good and positive thing. And I really appreciated my classmates at this point in time, like thinking about it, they were really supportive, they were really helpful, and we were more like a community. So we're working together and trying to learn from each other rather than like being okay, challenging or like maybe a different type of environment.
That's great to hear. So you're not really that self-conscious about it, and you had good company, and in the end, that really was a good thing for you. And in 2001, you began your studies in computer engineering at the American University of Beirut. What led you to that decision?
So a couple of things led me to that decision. First, my parents encouraged me, given that like I was good in math and physics, and like my grades allowed me to pursue that direction of computer engineering. Then they tried to maybe convince me or to provide me with this opportunity, like thinking about this opportunity. But also at the same time, during that particular time in Lebanon, like computer engineering was really highly appreciated in terms of finding jobs later on, and in terms also if you want to pursue higher studies like academic studies later on in abroad. So if you want to have a master's or even later on to have a PhD degree, then that degree provided you with this opportunity. And also if you want to find good industrial jobs, that was also the direction. So it provided me with different choices later on. And that was something that I wanted to be open, because I still was not decided afterwards what I wanted to do. And that flexibility of being a computer engineer was something that at that point in time, the American University of Beirut in particular, and the degree of computer engineering, this combination allowed me to do that.
Yeah, I teach to computer engineering students, the freshman students, and I ask this question every time, and you gave a similar answer compared to many of the students that I had. That's very interesting. Did you come across OR during your undergrad?
Yes, during the third year of my studies, I took a course Introduction to Operations Research, and that course was the first time I get exposed to operations research. And as I said, maybe choosing computer engineering was not because I wanted to do a computer engineering, like in terms of like coding or implementing certain aspects in computer engineering. And when I took this operations research course, something clicked in my head. Okay, this is something I'm interested in because I like coding, but not to implement an operating system or not to implement a network protocol, which was the main topics in terms of computer engineering. But I like coding to make things like really useful in practice. And this Intro to OR course like made me like think about things differently, and okay, I can use my knowledge or my courses that I've been taking, and we were solving like a traveling salesman problem, but also you can think about the implication of it in practice. So then I started seeing, okay, that makes sense to me, and I really like that we are implementing for something to make a difference or to be applied for companies or applications. And I thought that may be something I can do next, or I can think about for after graduating, and I would really like to do it.
Yes, and I can totally relate to that. Was a capstone project required for you to graduate?
Yeah, so there was the internship, like you needed to do a summer internship at the third year, and then afterwards you have to do a capstone project at the fourth year to be able to graduate. So for the capstone, it was based on my internship project. So it was in robotics. Again, it was not the area that I would have chosen now thinking about it. But yeah, like there were some options and some professors that were like had open projects, and that's what myself and my team decided to pursue. So it was, yeah, like a firefighting robot where you need to go around a given space and do some obstacle detection and obstacle avoidance and find a flame and turn it off. So that was my final year project.
That's very nice. And towards the end of your undergrad, you spent an exchange period in Waterloo working in robotics. How did that opportunity come about, and how was the experience?
Yeah, so actually that happened totally by a coincidence. So like during the third year, you need to apply for different internship positions to get this summer opportunity to go for 3 months abroad, or like in a different company to work in a company, or yeah, like either at a university or the company. And at that point, I only applied to certain positions, and Waterloo was not one of them. And I got an opportunity in the US, but it was in the civil engineering department. And I was a bit hesitant, given that it was like the US and I was traveling alone. I was the only one accepted there. So I didn't have any friends or colleagues going with me. And also, it was in the civil department. So it wasn't really clear to me that it's something that I wanted to do. So I reapplied for other positions again. So during the second round, I applied for other positions, and Waterloo was one of them. And I was really happy that I got an opportunity there. We were 16 people going from the American University of Beirut to the University of Waterloo, because there was this joint program between a professor there who's actually Lebanese and the American University of Beirut. And that was really something nice, because you can see like he's a Lebanese faculty member, and he was giving back to his country or community by like trying to bring people from Lebanon and getting them exposed to different like programs at the University of Waterloo. And it's a top university there. So it was really something nice to see that people are still connected, even though that they traveled and they've been living so many years abroad, that he was still connected to the university that he did his undergrad at and tried to help like students be there. So that was one thing that I found interesting. And also, like, we were a group of people going there, and it was in computer engineering department. So it was still in my area and in my field, and it was a robotics project. So we were going to work on a parallel parking robot. So that was really fun. The funny thing I would say is that I don't know how to parallel park. So in practice, I'm not really good at parallel parking, but in theory, I was able to do it and make this robot parallel park, especially like in Beirut, the parking spots are super tight, and you have to be really good if you want to do it in the city and park your car there. So yeah, and that ended up being a really nice project, and I was really happy to work with the team there and getting to know the university, and being at like the campus there and in Canada, which in general, like, it was my first time traveling alone. So yeah.
Yes, yes. But since you were in a group, I suppose that the adaptation was not that complicated.
Yeah, so we were traveling 16 students, and each was in a different department. So yes, we used to have lunches together or dinner together. We used to also explore the city around together. And then during the day, everybody was working in their own group and own department. But yeah, so you're definitely right. Like it provided me with an easy way to adjust and adapt and not feel like, okay, it's the first time moving alone or living alone in a new country. So we had this community feeling together. Yeah.
Right. That trip was also very good for you because you were able to connect with someone that became very special in your life.
Yes. So my partner at that point in time was at the American University of Beirut during like the undergrad years, but we didn't have the chance to meet until we did this internship at the University of Waterloo. So the city of Waterloo and the University of Waterloo have a special meaning for me, because there I met my partner and now my current husband, Joe. And we had a chance to connect and to, again, know each other a bit more, which we didn't have that chance during our bachelor's degree at the American University of Beirut. So it was also like by coincidence that things happen when you least expect. And I think that was a very nice coincidence to meet him there.
Yeah, so that trip was really a life-changing experience for you. Yes.
Yeah, I would say both on the academical side and on the personal side. Yeah, both of them, like being exposed to the University of Waterloo and to like the research also component, because I was doing research there. So I didn't know exactly what research means before that trip. And also on the personal side, meeting my partner and my husband and having that chance to meet somebody very special was like
Yeah.
good
Right.
time.
That reminds me of my parents because they knew each other in India, but they were able to connect for good in Canada. And guess where? In Waterloo. It's
Waterloo
yeah,
brings a lot of people together and yeah, opportunities.
yeah. I know you began your studies in semi-definite programming, or SDP for short, during your master's. Before we discuss your research on that topic, could you kindly give a brief introduction to it, if it's not asking
Yeah.
too much?
No, sure. Like just maybe to keep it simple, like semi-definite programming is an extension in some sense to linear optimization, and it's an optimization framework where you're using matrices there as variables, and you're optimizing either minimizing or maximizing a linear matrix objective function subject to a set of several constraints. And one of the constraints that are included is that the matrix variable need to be positive semi-definite, and which means that the eigenvalues of this matrix should be non-negative. And that really part, or that constraint, has a really powerful setup because it provides interaction between the variables in a way that linear programming doesn't. And it allows you at the same time to solve complex combinatorial optimization problems, certain complex combinatorial optimization problems that linear programming might provide like weak relaxations for, while a semi-definite programming, or SDP, would provide you with stronger types of relaxations. And that's really powerful for certain problems.
Yeah. And now let's talk about your master's work. What did you study specifically?
So for my master's, I worked on the minimum K partition, which is also known as the maximum K cut. So this problem is a partition problem. So you have a graph and you're trying to partition this graph into K subsets or K clusters. And your objective is to, in this case, maximize the weighted number of edges cut. Okay. So, or in the minimum K partition, to minimize the sum of the weights of the edges inside within each partition. And this problem has lots of applications in telecom, for example, in physics, and in other areas. And the way it started is when I joined the master's program, like with my supervisor, he gave me a paper and he told me, like, read it and see what you think about it. And it was a minimum K partition with an application of telecom, like a telecom frequency assignment problem. And it was really interesting for me looking at SDPs for the first time, and had no idea what SDP was, because I was familiar a little bit with linear optimization and mixed integer programming, but not SDP. And I
Like
worked
many
on
of
this.
us.
Yeah, I worked on this paper for 2 months before starting my master's. So I started in September of 2005, but July and August, I spent 2 months first reading this paper, understanding and gaining some knowledge in terms of the background of SDPs. And then we both decided, okay, that's a topic I'm interested in, and my supervisor was interested in having me as a student. So we decided to continue working together and to start my master's on the minimum K partition problem.
Mm-hmm. And how was the experience of presenting at an international conference for the first time?
Yeah, so the first time I presented, I was still a master's student, so it was towards the end. It was, I believe, in the summer of 2006. Yeah, it was the end of my master's degree. And then I was presenting the minimum K partition, the framework that we implemented there on solving this problem to optimality, which was, in other works, only done at like a relaxation or just bounds to this problem. What we did is we combined both like the relaxation as well as a good heuristic and a branch and bound framework to be able to find optimal solutions for this problem. And at ICC Opt in Hamilton in 2006, I presented this work for the first time. And I was really nervous, to be honest, because it was the international conference first. And then it was my first time presenting to our community, that has been working in this area, I would say, for many more years than me. So what I did is I practiced a lot. So I really practiced the presentation, and my supervisor was really helpful and supportive in terms of providing me with some feedback on the slides, for example, and in the structure of how, what areas to focus on, which ones not maybe to highlight, at least in the presentation, to keep it compact. And also in terms of the style of presenting, to make maybe to be a bit slower, so that the audience would know a bit more about what I'm talking about, because sometimes I tend to speak a little bit more quickly. I was really happy with the way things ended up in terms of the presentation, just because of the follow-up emails and the follow-up contacts that I got were really nice, and I was invited to some other follow-up presentations and seminars based on this particular work. So yeah, I was very happy meeting people in the area, and that was my first time in contact with them, and that's how my first conference went. And it also gave me an idea of what to expect later on for other conferences and workshops.
Mm-hmm. And ICCOP stands for International Conference on Computation Optimization, right?
Yes, yeah. Yes, it was for the continuous optimization community, working mostly on SDPs or convex relaxations. And that was why I was really very, not I would say stressed, but I really wanted to present it in the best way possible, because it's the community that I'll be part of in the years to come.
Sure, totally get it. You completed your master's almost 20 years ago, and at that time, there were hardly any solvers capable of addressing SDP problems. How did you manage to work around that?
Yeah, saying now 20 years, I think time passes very quickly, right? So I think it was yesterday that I started. But yeah, when I started my master's 20 years ago, solving semi-definite programming problems was very challenging. Because there wasn't any commercial solver that was well maintained or was continuously worked on. At that point, there was CSDP, which was based on C. And we used that for my master's degree, for example. But at the same time, it wasn't flexible in terms of how you call the function or how you can adjust a few things within the code. So it was a bit structured. And there was Sedumi also that was more user-friendly, but it was MATLAB-based, so it wasn't really efficient in certain cases to work with. So I really struggled a lot when working initially on semi-definite programming, and that's also why some people were hesitant to work in this area, because of its challenges in terms of computational complexity or computational efficiency. But for me, it was really interesting because I saw an opportunity there that not a lot of people are working in this area, but at the same time, it's very powerful in terms of bounds. So if there is a way that we can solve this just more efficiently, then we are able to solve really interesting problems and really interesting applications. We developed few things that were customized to certain problems that showed a lot of potential. For example, for the maximum K-cut, we had our own approach, although it was still using CSDP as a solver, but the branch and bound framework and the heuristic showed a lot of potential to solve globally certain sizes of this problem. And at the same time, later on in my career, and in my studies, there were a lot of applications that fit really nicely into SDP. And I'm really glad that now, we have Mosaic as a commercial solver to solve these problems, because that also made a lot of things easier and created a lot of exciting opportunities and exciting research in this area. And of course, there's a lot of other customized first order methods that are being developed and things of that sort, which are also becoming very active in this area.
Yeah. So the area is actually flourishing right now. Is it safe to say that?
Yes, I would have to say that a lot more research is being done in this area, and especially after the optimal power flow, for example, which was one of the applications in energy, became very popular. showing that SDP relaxations really work for this problem, and in some cases they are really optimal. I think people started seeing, okay, there's a practical application that's really interesting for not just the academic world, but also for companies. And that also provided the commercial solvers to work on this area, as well as more academic people and more people in research to work on this. So I'm really happy that I started working on SDP at that point in time. And now I'm even happier that a lot of people and a lot of research in our community is happening in this area.
Yeah, that's great. In 2007, you went to Germany right after completing your master's, correct?
Mm-hmm. Yeah. So I got the Marie Curie Adonet exchange or like visiting fellowship. So I went there to the University of Cologne to work with colleagues there. And it was really also, I would say, being just a master's student at that point in time and just finishing my master, it made me think that, okay, research is something that I really want to do and to continue working on. Although at that point I was working on abstract applications like the maximum K-cut or partitioning problems, but I saw some connection to, like, when you implement something and you see the solution and you see how things are being implemented, that was exciting for me. And the area of semi-definite programming, the way that I was introduced to it and the way that I worked on something that not a lot of people were working on, it also excited me. So it was something exciting for me.
Mm-hmm. In that same year, you started your PhD in polynomial optimization, which also included SDPs. Could you tell me a bit about your research?
Yeah, so I think at that point in time, I was really interested. Okay, we worked on a lot of abstract problems for the SDP, but I wanted something a bit more general to capture other applications or to capture general problems. And thinking about it now, like, it wasn't again planned. So a lot of the things that happened in my life were not exactly planned because it happens by coincidence, or you meet somebody or you talk to somebody, and that changes a lot of things in your life. And at that point, we had a visiting professor who worked on polynomial optimization and who also saw the connection between SDP and polynomial optimization and how SDP is really powerful in solving this on the abstract sense. Like from a theoretical point of view, given the hierarchies that were implemented by Lasserre's hierarchies, and how SDP shows like a really strong bounds for certain problems there. So when we met, we started talking, and eventually he became my co-supervisor. So along with Miguel Anjos, who was my master's supervisor as well as my PhD supervisor, who had a lot of influence in me going to an academic career and choosing to do a PhD. He was very motivating after my master's to pursue a PhD degree. And with Miguel and Juan being my other co-supervisor working on polynomial optimization, we found a topic that fits as a continuation of what I've been doing. And we started looking at general polynomial optimization problems, although I was seeing like different applications that can be applicable there and trying later on to connect with that. But at that point, we were again looking at them from an abstract point of view with some computation, like how we can solve larger problems of these types and how we can improve that from a computational point of view.
Yeah, it's nice to know that you guys were doing very exciting work back then. And what did you do after finishing your PhD in 2011?
So after finishing my PhD, like during the PhD, we had a couple of papers that are were submitted and being in the process of the peer review process. So it was a bit of a challenging period during the last year of my PhD because we had like two papers, one in SciAm-Opt and one in MathProg at this point in time. But at that point, they were still in the review process. So nothing was published yet. So I really needed to wait a bit for my CV to be stronger for an academic position. And I found an opportunity at the Department of National Defense in Canada for a visiting researcher position, still working on optimization and research, which was really exciting and interesting for me. And I decided to apply there and to see if I get the chance or the opportunity to join. And thankfully, I was able to get that position and work on inventory management problems for their aircraft fleet, like how to allocate spare parts and where to allocate these spare parts and how to allocate resources also within their facilities. So I still was able to work on optimization. It was a different like type of problem, a different application, not related to semi-definite programming, but I was still working on OR, and that was something really nice. And we were able also to publish one paper out of this work, which was also even like better from my point of view to publish on a practical application and something that worked for them as well.
Mm-hmm. And you spent a couple of years there, right? And in 2013, you crossed the Atlantic to work at IBM Research in Dublin. Was that part of your plan A?
Nothing was part of my plan A, to be honest. Like none of the things that I just mentioned were part of plan A. But so that position at the Department of National Defense was on a yearly basis. So at some point, I knew that either I need to find something more permanent or I need to find other opportunities. So I saw on LinkedIn an advertisement or an announcement for a research scientist position at IBM Research in Dublin, which was newly established at that point in time. And it said semi-definite programming, polynomial optimization. So all of these words like, okay, I'm really happy to see this because I've never seen them in any other job advertisements, especially at that point in time. So I felt like this position is really like very well connected to my resume, to what I've been doing. And it's a research position, so I can still publish and do the things that I wanted to do in terms of eventually, if I want to go back to academia, I can still be able to do that. So I applied for this position, and after ISMP in 2012, I heard back that I got this position, and I joined the group in 2013. So it was really something that I was excited about.
Yeah, and off you went to Ireland. And what lessons did you learn from this industrial experience?
Yeah, so Ireland was also not on my map in terms of places that maybe ending up being there. But as I said, the position was really interesting, and the group, like that, like the type of work that the group was doing was really very relevant to what I wanted to do. Especially during the interview process, I get the chance to know what they've been working on, and I were actually working on applications of semi-definite programming, which I haven't done during my PhD. For example, we worked on MaxCat, we worked on knapsack, quadratic knapsack problems, quadratic assignment problems. So problems that are still like you can see a practical side of it, but not directly connected to a practical problem. And that really excited me. And it provided me with the opportunity to work with companies that have problems that are of quadratic nature or non-convex quadratic problems. So I worked there on a water application, which required like pump scheduling. And there, a lot of the constraints were nonlinear or like quadratic non-convex. And we used semi-definite programming there and optimal power flow. So I worked also a lot. That was my first time I got exposed to this problem. And it was at the beginning of the hype where people started looking into this problem because they knew STP was working really well. But not a lot of research was being done there because, again, it just started. And we had a client, we had like a company that was interested in semi-definite relaxations for this problem, and I worked on that. So I started seeing this opportunity of how can I move my research that is a bit theoretical. Maybe STP was not able to tackle large-scale problems, but after exploiting certain structure in these network problems, after looking into particular aspects of the relaxations, you are able to tackle actual real-world problems. And that was really like rewarding in the sense that I felt, okay, these problems now or these techniques that I've learned or I've been working on for a couple of years, now I can see their impact on practice and how beneficial are they for certain companies or certain areas and certain maybe networks, I would say mostly.
Mm-hmm. How about the opportunity to work with a multidisciplinary group? How did you benefit from that experience?
So, like working with companies and working on real applications was one side of it, but also working with a team of interdisciplinary people. So we had, like, when we were working on the water application, for example, we had a colleague from environmental engineering that was working with us. When I was working also on the optimal power flow, we had people like working with a company with people who had electrical engineering background. And also, I worked a lot on other applications that machine learning was also part of that. And I got the chance to work with people who have expertise in this domain. So, getting me exposed to different people working in different disciplines was also something very beneficial that I see the implications of it even like now. And also talking to people in different languages, right? Like, so you want to explain to an engineer, like the mathematical model, you want to explain to a client the business implications of using this model versus using whatever they are currently using. So all of these things, and in addition, like working with technical people from different backgrounds, I think provided me with a lot of advantages that I can see in myself right now, like when I talk to people or I work with industrial projects or applying for grants, how you can frame things in a way that is better understandable with people from different backgrounds or coming from different disciplines.
Yeah, so you're kind of forced to develop different skills that ended up being super helpful in your career.
Yeah, this experience at IBM, I'm really very thankful for, although it happened just by a coincidence. But even though it was also a short period of time, I spent 3 years there, I think it shaped a lot of what I am now and the way like to talk with clients or to work on industrial projects, working also on writing grants, how you can speak about your research to people coming from different disciplines or having different technical terms to talk about. So yeah, I think that experience was really very positive, and I'm very thankful for it.
Yes. And you got married in 2014 in Ireland, and your husband returned to Canada in 2015. How did you address the two body problem?
Yeah, so after 10 years of being together, like in Dublin, Ireland, we decided to get married. We were both at IBM Research at that point in time, so we were both there. And then my husband got an academic position at the Ivey Business School. And that was in 2015, and he decided to go there, and because he really wanted an academic position, so I was very supportive of that, and I thought that would be really good for him, although he was also very happy with the experience at IBM Research. But eventually we both wanted to be in academia, and that was the first step where he moved to Canada. And then I stayed in Dublin for 1 year, trying to search for the opportunities and for jobs to be together at some point in time. But as I said, like there's the two body problem, and it's very difficult, especially in academia, because in industry, people like always try to find jobs, and usually it's easier to be close by. But academic positions, and especially in Canada, where like there's not a lot of them, and being in the same city or town is not easy. So we had this challenge.
Mm-hmm. But then you took the first step in 2016 when you returned to Canada to work at the University of Waterloo. How challenging was it to secure that position?
Yeah, so the next year, luckily, like, so we didn't stay apart for long, and he was commuting back and forth between Canada and Dublin. And at that point in time, I saw the job position for an assistant professor position at the University of Waterloo in the data analytics, which was in the management science group. So it was where I graduated from. So it was the department that I graduated from. So in some sense, I knew the people there. I know the environment. I know how things work. And that was maybe played to my advantage. I don't know, but I got the position there, and it was really nice to be part of the faculty members there and part of the community at the university, and being back to Waterloo rather than, yeah. So I felt more like a colleague immediately rather than somebody starting from scratch or somebody that, was a foreigner to that group. So I felt like directly it was a smooth transition for me to be part of the team there.
Yeah. And the following year, you moved to London, Ontario, where you eventually settled at the Ivey Business School while still staying connected with the University of Waterloo. Was this a difficult decision to make?
Yeah, it was a very difficult decision, I would say. So when I joined the University of Waterloo, eventually, I knew that I wanted to start a family, and commuting, especially this year that I was commuting in the winter between Waterloo and London, because we were living in London and I was the one commuting back and forth. I felt it's gonna be a struggle continuing this for the next years. So we had to take a decision at that point. Either I moved to Ivey, or my husband would move to Waterloo, depending on what positions open up. But that was the long-term plan. Like at some point, we need to be in the same place, especially like if you want to start a family and with young kids, or that would be a bit difficult. So the next year, a position opened at Ivey, and I applied for that position. Although it was really difficult for me to leave Waterloo, given that I started establishing a team, I applied for a grant. I started also establishing some collaborations with different groups and different departments. So I felt like I'm settled, so I can like start something there. But then it was a quick move again. So that 3 years between IBM Research, Waterloo, and Ivey, there were a lot of changes. But luckily, things were stable eventually. And the move to Ivey, although I was a bit worried, like it's a business school, it's a bit different from what I used to be honest, it was very smooth. And I really am excited about the way like things went. The way they teach case-based teaching, it was something I was also a bit not sure if it's easy to do at the beginning, or you need time to set it up or to get used to this framework. But it was an easy ride, and I'm very happy. Also, like everything again happens for a reason, and I'm very happy with the things turned out, how they turned out.
I'm very happy for you. So let's talk about your research work now, especially from the past 10 years. I noticed that you've worked on a variety of problems related to optimizing the design and operations of smart, sustainable cities. Why don't you start by talking about the problems arising in energy systems and water networks?
Yeah, so that work started with my work at IBM Research, where we had different projects on energy and water networks. The nice thing about these problems is they share a lot of similarities, although like one is in energy, one is in water, but the network themselves that are sparse, they have a particular structure. And at the same time, the physical constraints within the network itself, they have a very similar structure. So on the energy side, there are the power flow equations, which are a non-convex quadratic. And also on the water network side, we have the friction loss constraints, or the friction constraints that make also non-convex quadratic constraints. So these, whatever methodology you are able to apply for one, you can really easily extend to the other. And I found a lot of analogies and similarities there, that we were able to solve these problems like really efficiently using STP relaxations, and at the same time exploiting the sparsity of the STP relaxation, which allowed us to really tackle large scale networks, which was not possible before.
Yeah, that reminds me a bit of routing and scheduling, where you can reuse a lot of things that, for example, you do when working on routing problems, and you can apply to solve also scheduling problems. Still in the context of smart, sustainable cities, could you talk about your work on transportation and telecom?
Yeah, so these two other applications, although they have also a network structure, they are also under the, I would say, umbrella of urban networks. But there we didn't go into the physical constraints or the nonlinearities of the constraints that are present in these networks, but we looked more at it from a mixed integer linear optimization point of view. And we tried to move to a more sustainable transportation network or a sustainable telecom network. From the transportation side, how we can incorporate electric vehicles, and given the uncertainty in electric vehicle range, to service customers or to service like delivery services. And on the telecom side, how we can minimize the energy consumed, given that there's a lot of in terms of edge computing, and in terms of, especially now, the amount of consumption of like these devices in terms of energy, like it's really growing exponentially with the computing power, or within the what these small devices can do in practice. So we try to limit the amount of energy that is being consumed, and try to take uncertainty either in the latency, which means like we really want quick responses, or uncertainty in the demand. So we looked at the mixed integer programming formulation for these problems, and then look into the uncertainty, how we can incorporate realistic constraints related to the uncertainty and solving these problems.
Right. Sharing economy is also part of research agenda, more specifically optimizing the use of shared resources in energy and transport. These are mostly business applications, right?
Mm-hmm. Yeah, so this again, I started at IBM Research working on car sharing, and we did a paper on how we can incorporate, for example, Twitter data in terms of having people commute with other people who they share similar interests, for example, or similar topics. And at that point in time, that was a few years ago. But we try to look at data-driven type of approaches that can allow you to share assets or to share cars in this particular case. And I found that this topic also relates to now when I'm working in a business school. Like you can see a lot of business models that come out of the sharing economy, a lot of sustainable advantages to using shared resources. And although I worked a lot on technical things from the STP relaxations and polynomial optimization and other technical work, I think this still is appreciated in the business schools. So I didn't find I need to change any of my research in terms when I moved to Ivey. But at the same time, having these applications that I got when I was working at IBM Research from the sharing economy, I've added some additional value because now I'm working also on business models, business applications that are also very relevant to people that I can collaborate with here in the business school.
Right. So you described interesting lines of research. The first part, let's say, was related to more methodological contributions, and the latter part was more in the business sense, right? I mean, you have been working on STPs, and then you mentioned now robust optimization. These are methods that require some, math background and also computational background to implement the algorithms efficiently. How do you see that being deployed in practice? Is it something that can be envisioned in a short term, or is it still something that may require some time to be, embraced by the industry?
I would say the best papers or the research publications that we've done is the one that combined both, like that had a strong methodological contribution, but at the same time, we were able to show at least it works in practice or on real data sets. And I think companies are really interested, especially like when I was working again at IBM Research, when they saw the value of semi-definite programming, and when we were able to tackle the large instances that they had in their data sets, then they saw, okay, it's something worth investigating and worth like maybe showing as a proof of concept how we can use that in our work. So I think, yes, we are at a stage where things are possible in terms of going from semi-definite programming to the theoretical methodological side to practice, and also polynomial optimization, which a lot of theoretical work has been done there. But I think now, like having faster computational methods to solve polynomial optimization problems are available, and we are able to tackle some interesting problems with these methodologies. So I think that's the next best thing, like how you can now use these things in practice and showing their value.
Mm-hmm. And speaking about polynomial optimization, you have been making some efforts to solve large-scale problems. What type of strategies have you been studying to achieve this?
Yeah, so there are two research directions that we've been working on this side. So one is finding tight and cheap relaxations. So how we can find strong relaxations from the STP world. So going from that sense. At the same time, cheap, because we want to solve like instances in a short amount of computational time. And exploiting the structure was one way of doing that. So that I think provided us with a lot of advantage, especially the network structure that the instances we were working on, whether it's energy or water, they had a really sparse structure, and that was very helpful. So that's on one side. And on another side, we started exploring in the last couple of years how we can use machine learning to solve these problems more efficiently and try to bridge these two communities together of machine learning and polynomial or nonlinear optimization. There has been a lot of work on machine learning and mixed integer programming on the linear side of things, but not a lot on the nonlinear side. And I think this work of how we can take advantage of machine learning to help us solve larger instances of polynomial optimization is something that is exciting for me, at least in the next short term, in the next few years, to work on that. And also to see the impact of machine learning actually help polynomial optimization.
Yeah. And how have you been using machine learning to enhance the performance of solution approaches in the context of polynomial optimization problems?
Yeah, so I knew about machine learning and its, I would say, power or its advantage in terms of optimization when I was at IBM Research, but I didn't like put my hands dirty in the sense that worked on these types of problems. So I started looking at the machine learning at that point in time, and it was always on my mind that it's something I'm excited about. I would like to see if I can integrate it with the current work that I've been doing. And in, I think, 2018, at ISMP, I met the group from the University of Santiago de Compostela from Spain. They presented their work on polynomial optimization using Raposa, which is a solver that they developed. And it was really competitive because it was able to tackle large-scale polynomial optimization problems. So I thought that, okay, they have this interesting solver, and then if we can really adjust things within the solver and see based on different things how things are working or how things would perform based either on different relaxations or different type of cuts or different type of branching approaches, that would be really something interesting. And you cannot do that with really a commercial solver. So because you really need to have all of the components of the solver like accessible to you or to stop any pre-processing. So for that, I felt like, okay, this is really interesting. And luckily, the group also attended my presentation at ISMP, and we talked afterwards. So we had a discussion, and we saw, okay, maybe we should collaborate. We didn't specify machine learning at that point in time. We thought, okay, let's see how like our forces can combine in terms of me working on relaxations of polynomial optimization problems and their Raposa solver. And then we started talking online and having meetings. And at some point we converged, okay, let's work on this machine learning approach. And as a first step, we started looking at the branching rules. And for that, because we are working with polynomial optimization problems, it's not like the standard branching that you do in integer programming where you branch on variables either being 0 or 1 or integer. There you have to use spatial branching. And for spatial branching, there are different ways to do spatial branching and to select the variable and how to divide the bounds for that variable. So there we try to think about that particular characteristic of the branch and bound tree for polynomial optimization. And there we thought, okay, is there actually a space to learn from these branching rules? And actually, will some of them be more beneficial than others for certain problems? And when we did some testing, we did some preliminary testing, and we saw, yes, there's a lot of diversity in terms of how certain branching rules perform for certain problems, and that encouraged us to apply a learning technique. So that was the first step we've taken, and we were able to achieve like really reasonable results for that. And I believe like it was 23% improvement over using just one rule over all the problems. And that was the first step. And as a second step, we looked into cut generation. And are there particular cuts that are, again, more beneficial than other cuts for certain problems? And we looked into exploiting their conic cuts versus linear cuts versus the standard RLT relaxations. And we found also another improvement there. And we're building now, like on top of this work, like the dynamic aspect of learning. Can we actually do something different at each node of the branch and bound tree rather than just choosing one or learning one at the beginning and doing this throughout the branch and bound tree? But can we actually be a bit more like dynamic there, or like at each node to select a different rule that might be provide us with a better advantage? So we're building over these. So what I'm trying to say, yeah, like this work started some time ago, and it was again by a coincidence from a conference that we crossed paths, and we are continuing this work for the past, I believe, 6 to 7 years, and it's still an ongoing collaboration with the University of Santiago de Compostela. And yeah, it's a very exciting research group, and I'm happy to be able to collaborate with them.
I think this looks really promising. Maybe the people from the combinatorial optimization community can borrow a few of these ideas to improve the performance of the algorithms developed in that area. And as an associate editor for the Euro Journal of Computation Optimization, what is your general impression of the papers submitted to this journal and others in the field, especially those exploring the connection between machine learning and optimization?
being an associate editor is a really nice service that we do for the community, so I'm very happy to do that. The challenging part usually is to find like reviewers who are really good in what they do, and at the same time being able to deal with the timeline that we're working with. So I know people are mostly busy, and sometimes it's difficult to find reviewers, but that's one challenging aspect. Also, another challenging aspect, not being an associate editor, but being a reviewer in our community in general. So I review several papers throughout the year. And I would say one of the challenges recently that I've been finding is the integration of machine learning with optimization. Just following up on our discussion on integrating machine learning and optimization, is things are a bit done sometimes in a repetitive way, or like in a black box type of framework. And that's, as a reviewer, I find it a bit challenging that seeing a lot of these papers is not what research is about, so at least in our area. And we would like to have more, like, whether on the methodological side, to be able to tackle these problems by integrating machine learning and optimization, and having either like some guarantees on the solution, or having something a bit more methodological, or being able to interpret why are you using this particular tool, or can you actually interpret what's going on? Is it trustworthy to present such a solution? And using it as a black box for certain problems like VRP or any other type of application is not something I would say like as a contribution I see to our field. And people need to be a bit careful about that, and try to think more about how they can contribute, whether to the methodology or to the application, and how they integrate these two tools in a proper academic sense.
I fully agree with you, and I share your concerns. People, they try to take advantage of the hype at times, but they should do it in a serious fashion. They should actually care about the methodological contribution, instead of trying to, do a framework composed of, black boxes, just to suggest that you were trying to do something that is modern or even fancy, right? At times they're able to succeed in, because there are just so many papers popping out, but I'm not really sure this is the most promising way of doing it. That's why I appreciate your thoughts, and I think you have shared very valuable insight on the topic.
There's a lot of opportunities for machine learning to be combined with optimization. So I don't want to say that I'm discouraging that. It's just need to be done in the proper way and in the right way to provide this integrating two communities within each other, and having a proper research framework around that.
Yeah. I'm looking forward to seeing something more organic than something that is artificial, pun intended, because it can create also a lot of noise, and with this large amount of papers being published, and suddenly you see them making comparisons, overlooking serious optimization algorithms, and it starts to create a non-desirable tendency in research practices when combining these two worlds, right? So yeah, I insist, and I agree with you that we should be really, really responsible when conducting this type of research, also, and also when reviewing this type of contributions, right? And what is your approach when it comes to supervising students?
Supervising students is really important for me. I had a really good experience during my graduate studies, and I try to also have that for my students. I do weekly meetings with my students. I'm really on top in terms of the topics they're working on, or any particular struggles or issues. And they also have my contact info. So if they have in any particular day, some problem, like a quick problem that they need to discuss, they know how to reach me. I really enjoy the supervising part, because also it's more like a sense of collaboration. You're collaborating with people. You're also gaining knowledge and experience with that. And some of my students are abroad, so I'm co-supervising students with colleagues in Europe, for example, and we still meet via Zoom on a weekly basis. And again, they can send me either emails or chats throughout the week to have any discussion. And I really take extra care of my female students, just for me, because I'm a female faculty member, and I feel like any of the difficulties that I might think about that they might encounter, I would like them to be prepared for that. Like having confidence is one of the important things that I try to emphasize. Like you can do it no matter what problems or issues you face. You can just stand up again and move forward. I try to help them with my network as well, to either like participate in conferences as much as possible. So yeah, like being a female myself, I think that is something I'm careful about, and I would really hope that my female students, like whatever issues they are facing, like I have an open door policy, whether by like physically in presence or by email or contact, to talk to me about it and to help them through whatever they are facing.
That's fantastic, Bissan. It's great to hear that you are providing all means of support to assist and to help your students, especially the female students. Very inspiring. And what has been your strategy to balancing maternity and work?
I don't think I did a good job at that. So my two kids are very young. One is 6 and one is 2. And both of my maternity leaves, like the two of them, I wasn't teaching because like I took a maternity leave, but everything else I was doing, like the research meetings, the follow-up with my students, the reviewing the papers. So I felt like I didn't pause and just enjoy the time with my newborns. Maybe looking back at it, maybe I should have done it differently, but I think our work and the way things, like there are students that you need to keep supervising, there are papers that you need to keep reviewing, and grant applications that have certain deadlines. So we're always, like we cannot pause, we're always on a fast pace, and we're always working. With my second child, I was a bit better. With my daughter, I was a bit better because first it was the summer period. So she was born during the summer. So things were a bit less busy in general, and the meetings and the supervision. So I was able to take 2 months, like completely to focus on her. And then the rest of my maternity, I was back to a more or less a normal pace. But my advice is to pause and to take this time to enjoy the time with your kids. And yeah, like these are like the 6 months or the couple of months that you're going to take in terms of maternity leave. These are like nice moments. I know I didn't do them, but now looking back, I wish I did.
Yes. I mean, I'm sure you're doing a hell of a job as a parent, as you are as a academic.
Yeah, I try to balance as much as possible. And the good thing actually also, like with my kids, I had a couple of research visits when they were young, and I always took them with me. And no matter where I wanted to go, or like a conference or a seminar or a workshop, I was able to take them with me. And thankfully also my husband is a really great support. So I'm very happy to have him by my side. And because we're also both in academia, I think that's also a good or a positive side. Like we had the opportunity to bring them with us, and we can then alternate between the two of us to make things work and to have a good either research visit or a conference and things like that.
But that's very nice. I mean, having your young kids attending conferences, maybe they can get inspired.
Yeah, and then one place I had them attend my talk, and they were like Leo, like my son, he was very quiet, and he was able to sit through my talk. I hope he will remember it at some point, but at least he didn't do anything unpredictable, so that was also good.
Yeah, because you were presenting and then you had to keep an eye on him by instinct, maybe,
But
right?
my husband was with him, so he wanted also to attend. So he had some supervision, but you never know with kids at a young age what they can do. But he was fine throughout the talk.
Yeah, but these experiences at an early age certainly have a great impact in their upbringing. And I mean, you're giving a very nice example. I hope they have a very good future ahead of them, right?
Thank you.
So, Bissam, as a role model in our field, would you like to leave a final message for our viewers and listeners, especially for the younger generation striving in Lebanon?
Yeah, sure. Like I would say, believe in yourself. So that's really something very important. And maybe I leave them with a phrase that my dad told me when I was very young, and it's stuck in my head. And I would like also to pass it to the young females, especially in Lebanon. Like, so he used to tell me, like, when you climb and you reach the top of the mountain, at that point, like, you'll see other mountains that are even higher. And these are the ones that you need to reach. And you keep going this way. And that would motivate you to really nonstop and keep moving forward. And whenever you fall, you just stand and go forward again. So having your goals and your big picture as a target, and not getting distracted in the small falls or the small hiccups throughout the road, that's really important. Just keep an eye on the target, which is the top. And whenever you reach that, think about other things that are even higher that you want to reach, and keep going.
I think you have just described an optimization algorithm.
I didn't think about it until now you say it, but okay, that's true.
Yeah, when I used to teach about the gradient method, it's like, you look for the top of a mountain, and then once you're there, then you like to go and follow the direction that might lead you to, again, promising peak and a different mountain, let's say. So
but the optimal is unbounded in this case, right?
Yeah.
Like, so in my dad's point of view, the optimal was unbounded because it keeps improving.
The sky's the limit.
Yes, yeah.
The sky's the limit.
But I agree, and it's a nice analogy that I never thought about it. But yeah.
Yeah, it's nice that you have able to achieve many things and possibly applying optimization procedures in your own personal life. So that's very interesting. Okay, Bissan, it was lovely to have this conversation with you. You were such an adorable person. I've learned a lot. I had to study a bit of semi-definite programming to interview you, but it was also a nice experience. And I hope you had a great time.
Thank you so much, Anand. It's a pleasure to be part of your series, and thank you for what you're doing to the community. It's really great to get to know different people and what their personal life or their personal touch, as well as their professional and academic careers. Thank you, Anand.
Yeah, thanks a lot. I'm also particularly happy that you are my first Lebanese guest, and I always feel excited when I get to interview someone that comes from a new country. So that's also nice.
Thank you so much.
Yeah, so take care, and I wish you all the best in your upcoming endeavors, especially your research activities. And also, I wish you the best of luck, balancing and juggling between, family and work. But I'm sure you're going to do really well. So I hope to meet you in person one of these days. Yeah. And if you're interested in visiting us in Brazil, don't hesitate to contact me, okay? Yeah, definitely. I will do that. Thank you so much, Anand. Okay. Thanks a lot, Bissan, once again. And see you one of these days. Ciao. Yeah. Bye. Bye. Bye-bye.